everyone, welcome to my channel. Happy New Year and happy 2026. Hope everyone have a wonderful year. Today we are talking about Amazon Cognito. Amazon Cognito is an identity platform for web and mobile apps. It acts as a user directory, authentication server, and authorization service, supporting OAuth 2.0, SAML 2.0, and OpenID Connect, OIDC. Cognito is rarely just one thing. You are likely targeting two distinct components that often work together. Understanding the difference is critical, because the impact of exploiting them is vastly different. User pool is normally used for authentication, IDP. The front door handles sign up, sign in, MFA, and account recovery, issues JWTs, ID token, access token, harvest emails, usernames, bypass MFA, modify user attributes, privilege escalation, or create an unauthorized account. Identity pool, authorization, the keys to the kingdom, exchanges tokens from user pools, Google, etc. for temporary AWS credentials, obtain AWS credentials to access backend services like S3, DynamoDB, or Lambda directly. Reconnaissance, gathering the key before you can launch any attacks. You need the public configuration keys. They are not vulnerabilities themselves, but they are the necessary inputs for your tools. Where do you find them? We can look into Burp Suite, look at HTTP traffic during the login or sign-up flow. We could look at the source code, search for client-side JavaScript, for example, main.js, apphandle.js. What are you looking for? Region, US is the one. User pool ID, client ID, identity pool ID. Note, if you find identity pool ID, because you may be able to touch AWS resources directly. Component 1. User pools. Authentication attacks. These phrases focus on the application layer, login, stealing an account, or becoming an admin within the app. A. User enumeration. Cognito often leaks user existence via error message. This helps you build a valid list of targets for password spraying. Technique 1. The restoration attack action. Try to sign up with a target email, for example, admin@company.com. Vulnerable response. Username exists, exception. You now know this email is valid. Secure response. A generic message or no error. Technique 2. The password reset. Action. Trigger the forget password flow. Vulnerable response. User not found expectation. User does not exist. Code delivery details. User exists, OTP sent. Technique 3. Login errors config. Look for prevent user existence errors. Vulnerable returns user not found expectation if the user is missing, but not authorized expectations the user exists but the password is wrong. B. Attribute injection. Privilege escalation. Cognito user have attributes, email, phone number, costume role. Costume is admin. The flow. Developers sometimes allow the app client to have the right permissions on sensitive custom attributes. The attack. Create a low-level account. Inspect your JWT ID token in jwt.io. Then find the custom attributes. For example, custom is admin. Use the AWS CLI to overwrite the attributes on your own profile. The command AWS Cognito IDP update user attributes, followed by region, access token, and use attributes. Name equals costume is admin, value equals true. The result, if no error occurs, log out and back in. Check your token, you may be an admin now. C. Bypass restrictions. MFA bypass. If MFA is set to optional, a compromised password is all you need. Resistant restoration. Even the UI has the sign up button, the API endpoint is often open. The command could be like this. AWS Cognito IDP, sign up, followed by region, client ID, username, and password. 4. Component 2. Identity pools. Authorization, cloud attacks. This is critical cloud hit. They are moving from hacking the app to hacking the infrastructure. Unauthenticated access, the guest hole. Context. Developers often enable authenticated identities for apps that need to download public S3 content, like images, before a user logs in. The risk is if the permissions attached to the guest role are too loose, you can steal data. The attack requests credentials as a guest without login. The command could be like this: AWS Cognito identity get ID, followed by region identity pool ID, get credentials. The command could be like this: AWS Cognito identity get credentials for identity, followed by region identity ID. Result: you can get an access key ID, a secret key, and section token. B. Authenticated access. Rule authentication. Contact: even if you must log in, the rule assigned to authenticated users may be dangerous. The attack: log into the user pool to get your ID token. Exchange the identity ID for AWS credentials. The command can be like this: AWS Cognito identity get ID, followed by region identity pool ID and the login Cognito IDP. Region: Amazon's AWS.com. User pool ID equals ID token. C. Exploiting the credentials. Once you have the AWS keys, access, secret, and section token, config them to your terminal. Now, enumeration: what you can do. Check identity, run AWS STS get caller identity. Check S3 buckets, AWS S3 list bucket for private data. Or run DynamoDB, AWS DynamoDB list tables. Or run check the Lambda, AWS Lambda list functions. 5. Security features. When pen testing, beware of these defenses. Adaptive authentication. Cognito minus traffic patterns. If you brute force from a single IP, you will get blocked. Bypass. You can rotate IPs. Compromise credentials check. If you try to sign up with a password like password 123 exclamation mark, Cognito might reject it because it appears no data leaks. WAF integration. If your automated tools like Pacu start filing with 4 or 3 forbidden, check if AWS WAF is blocking your user agent or request rate. The tools we can use for run the attack. First, we all know AWS CLI. This is a standard tool for all menu commands above. Pacu is designed by Rhino Security Labs. They have Cognito enum module. Is automated enumeration of settings. Or Cognito attack, we could use Burp Suite. It helps analyze tokens and identity configurations. And JWT.io is essential for decoding the token, understand the claims you are targeting.